The humble fork, an object so common, hides centuries of mechanical innovation within its simple design. This everyday utensil leverages fundamental physics, making it far more powerful than you might ever imagine. We grip it daily, barely noticing the intricate engineering that allows us to effortlessly spear and lift our food. But what exactly makes this seemingly basic tool so incredibly effective at its essential task? From its earliest forms, the fork represented a significant leap in human interaction with food and dining. It transformed eating from a messy, finger-based endeavor into a more refined and controlled experience for everyone. Understanding the fork reveals foundational principles that govern nearly every mechanical device surrounding us. It demonstrates how form, material, and human interaction combine to create indispensable functionality. At its core, a fork operates as a sophisticated lever system, amplifying the force of your hand. Your fingers provide the effort, the tines engage the food, and your wrist or palm acts as a subtle fulcrum. This arrangement allows a small amount of effort to exert significant pressure on even tough food items. Consider the tines themselves, designed with sharp, tapering points, much like tiny, efficient wedges. These points concentrate all the applied force into an incredibly small area, easily piercing solid matter. But that's not the strangest part. The fork's true mechanical brilliance extends far beyond simple penetration. Imagine pushing a blunt stick versus a sharp needle. The needle requires far less force to penetrate. Yet the tines are not merely sharp. Their precise spacing is equally critical for holding food securely. If tines were too close, food would not fit. Too far apart, and the food would simply slip through. There's another crucial element. The material choice also contributes immensely to its overall performance. Most forks are crafted from durable metals like stainless steel, chosen for their strength and rigidity. This metallic composition prevents the fork from bending or breaking under the normal stresses of eating.
A flimsy plastic fork, though inexpensive, demonstrates this principle by struggling with firmer foods.
Furthermore, the handle's ergonomic shape allows for a comfortable, secure grip, preventing slips during use. Contact with your hand demonstrates this principle by distributing struggling with pressure evenly. This thoughtful design minimizes fatigue and maximizes control, enhancing your overall dining experience. Wait until you hear what comes next about the fork's unexpected mechanical versatility. Beyond its primary function, the fork also serves as a crude cutting tool, using its tines to separate food. You can even use the flat back of the tines for mashing softer items, showing its multi-purpose utility. The subtle curve of the tines and bowl-like shape of some fork heads aids in scooping loose foods effectively. This design prevents food from tumbling off, ensuring it reaches your mouth efficiently and cleanly. The weight distribution throughout the fork is also meticulously balanced for ease of handling. A well-balanced fork feels natural in your hand, becoming an extension rather than an awkward tool. Consider the small dimples or patterns on some handles, designed to increase friction and improve grip stability. These tiny details, often overlooked, contribute significantly to the fork's overall functional superiority. And then something unexpected happened, as humans adapted the basic fork design for specialized uses. Different cultures developed unique fork styles, from two-tined serving forks to delicate dessert forks. Each variation optimizes specific tasks, showcasing the adaptability of this fundamental mechanical concept. Even a simple salad fork, with its broader, flatter tines, demonstrates an adaptation for leafy greens. These design modifications highlight the engineering thought embedded in even the most common implements. The consistent element remains the core principle of leverage, force concentration, and material integrity. This intricate interplay of simple physics makes the fork a truly remarkable piece of engineering. The widespread adoption of the fork profoundly influenced culinary practices and table manners across societies.
It allowed for more diverse food preparation, as dishes no longer needed to be easily eaten by hand. This seemingly minor invention contributed to the evolution of elaborate dining rituals and social etiquette.
Think about how many other tools, like gardening hoes or rakes, utilize similar leverage and time principles. The fork's success underscores a crucial lesson. Effective engineering often lies in elegant simplicity. It reminds us that fundamental mechanical principles govern the functionality of countless objects we encounter. From complex industrial machinery to a simple household tool, the same physics principles apply universally. This realization offers a new appreciation for the cleverness embedded in everyday items surrounding you. The fork's journey from a luxury item to a common necessity reflects human ingenuity and adaptation. Its design has remained remarkably consistent for centuries, a testament to its enduring effectiveness. This longevity proves that robust, user-centric design stands the test of time, resisting fleeting trends. It impacts our daily lives by making eating more efficient, hygienic, and ultimately, more enjoyable. Without such simple innovations, our dining experiences would be significantly different, perhaps less refined. The fork embodies the spirit of problem-solving through mechanical advantage, a timeless human pursuit. It highlights how small adjustments in design can lead to enormous improvements in user experience. This humble tool quietly champions the power of applied physics in our everyday existence. The fork stands as a silent monument to the profound impact of simple machines on civilization. Ultimately, the fork exemplifies how fundamental mechanical principles power even the most basic, essential tools. If you found this hidden engineering fascinating, subscribe for more incredible stories about everyday wonders. Let me know in the comments what other seemingly simple objects you want us to explore next.